Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I'm dealing with spectroscopy. This is lecture number 13 and particularly in ultraviolet visible spectra, these terms are very important: chromophores and auxochromes. So first of all, I'll take chromophore. It is a Greek word and actual meaning is color carrier. The meaning of chromophore is color carrier. The one who carries color is known as chromophore. Okay, so let us examine two different compounds. Like if you see benzene, this is the structure of benzene, and you know that benzene is colorless liquid, so it is colorless. And the moment you put one functional group on top of benzene, like NO2, this is called nitrobenzene. And now nitrobenzene is pale yellow. Similarly, if we take aniline, theoretically it is colorless liquid. Of course, it imparts color in presence of air because of oxidation of aniline, but in fact it is colorless liquid. But when you will form azo dye from aniline by chemical reaction with beta-naphthol in presence of NaNO2 solution, then it will form this azo dye and it shows orange-red color. So here you can see that by imparting certain functional groups on this compound, organic compounds, we can see color. Okay, so some organic compounds are colored because of the presence of certain functional groups like NO2 group, azo group, N double bond N. This is called azo groups. These groups which are responsible for color. So the functional group which is responsible for color, color is known as chromophore. Okay, so chromophore is basically a functional group which imparts color. This is according to old definition, but nowadays we consider this the new definition of chromophore is like that chromophore is an unsaturated functional group. So this is the basic condition, that it should have pi bond, unsaturated functional group. In organic compound. Second condition for chromophore is that chromophore should absorb UV visible light or radiations of range of 200 to 800 nanometer. This is the second condition for being chromophore. Because of unsaturation, chromophore show electronic transition by absorption of UV visible light from BMO pi orbital to ABMO pi orbital. It is also known as pi to pi star transition, that I will explain you later on, but at present you should understand like this, that electron transfer from pi bonding molecular orbital to pi anti-bonding molecular orbital. Okay. Sometimes chromophore may shows strong absorption of UV visible region and due to electronic transition from non-bonding orbital to ABMO pi orbital, that is called pi star orbital. Okay, so this way we can see this effect of chromophores. There are certain groups of chromophores, and examples are N double bond N, NO2, then C double bond C, C triple bond C, C double bond O, C triple bond N, etc. So these are all considered chromophores because they are responsible for color in the compound. Now next part is oxochrome. What is oxochrome? Let us see this one. If you will see benzene, it is colorless. Nitrobenzene, it is pale yellow. But Paranitrophenol. It is dark yellow. Why? Because of presence of OH group. Okay. So, according to old definition, a group that could not could enhance the color imparting properties of a chromophore without being itself a chromophore is known as oxochrome. So here OH group is oxochrome. Why? Because it will increase the color of nitrobenzene. So these are the examples of chromophores like OH, OR, NH2, NR2, etc. So you will see the certain things in chromophoric groups, very important and very different from others, like this one. You will find at least one lone pair of electron. Okay. So what is the main criteria of functional groups? That oxochromes exist. First thing, all oxochromes are saturated functional groups. Then they should have non-bonding electron pair. They enhance color given by chromophores. They themselves cannot produce color. Okay. So that is the main criteria of this functional group. For example, if we see benzene, benzene is having chromophore. Benzene itself, because it has C double bond C, but there is no oxochrome in benzene, and lambda maxima is about 255 nanometer and epsilon maxima is about 203, and that is why it is colorless. But if you take aniline, then it is having benzene as chromophore and NH2 group as oxochrome, and you will find lambda maxima 250 nanometer and epsilon is about 1430 nanometer liter mole inverse centimeter inverse. Here you can see that NH2 group increase the color, and that is why you may find aniline colored in presence of air. Okay, or paranitrophenol is also colored because of the presence of OH group. So certain groups are oxochromes, and they sometimes increase bathochromic shift also. Thank you so much.